So these are the list of tasks that are mentioned here that we are going to do. The first is reading of the data, then we filter out the outliers from the data, then we combine the data using the pandas merge, and then we sort the data as well, and then we use the C1 package in order to create a regression plot to see the correlation. Obviously, the first thing we do is import the libraries, the pandas, then matplotlib.pyplot, and as well as cbound. Then the very next thing we do in our cell is loading of the data. The first data frame is called the temperature data frame, and the second data frame is the rainfall data frame. This is the location for the temperature, yearly temperature file, and this is the location for the yearly rainfall file. And using pandas dot read csv, we actually load the csv files. Then once the file is loaded in the previous cell, we jump to this cell and we display the loaded data frames, and you can see in the output both the data frames have been loaded. Then we move to the scatter plot. To plot the scatter plot for temperature data frame, use dot plot and dot scatter. This is the type, and then we place the x-axis as the column year and y-axis as column temperature, and label we give as temperature and year. So to show the plot which is plotted here, we use dot show from matplotlib, and in the output you can see as x-axis year and y-axis temperature, the points have been plotted in a scatter fashion, that is the scatter plot, and the label is given as temperature and year. Then what do you mean by outliers is, you can see at the topmost there one point is very much separate at a good distance from the remaining points, and one point is also at towards minus 150 degree, which is also called the outlier because it's very far from the rest of the points which are almost together. Then also we come for plotting the rain data frame we created. Again we use the dot plot and dot scatter, then we mention the x-axis, then y-axis against which we are plotting, and then we also name the label. Similarly, using dot show, we show the plot. Here you can see at the topmost you have one outlier, you have the label rain and year, and rest of the basic points are almost together, no outliers. X-axis is year and y-axis is rainfall as mentioned in the parameters. Then let's move to the next one. Then we use a filter to remove the outliers in the temperature data. As I mentioned, some outliers are there in both the previously formed plots. Now what we do in this cell is we remove those outliers. First we will remove for the temperature data. So we place a condition here like temperature less than 40 and temperature obviously greater than 0 in order to remove the negative part of the plot, and in order to remove the topmost outlier we use temperature less than 40. These are the conditions given, and this we are doing by using the dot query functionality, and we are operating this on the data frame, the temperature data frame, and we store all this selected data frame in the data frame filter. Then we can display the let's say first few rows of the filtered data frame, and using the display function, this is the output you get. The very next thing we do is plot the scatter plot for the filtered data frame. So again we use dot plot and dot scatter, then we name the x-axis and the y-axis, also the label. It's almost similar to the previous one that we did for the original temperature data, and then we use dot show function to show the plot. And now you can see here 40, which we mentioned in our condition, and the outliers have been removed. The points are almost close to each other. Now again for the rainfall as well we can do similarly. Using dot query we can put a condition and try to remove the outliers, the negative part and the topmost outliers are removed by this condition, rainfall less than 6 and rainfall greater than 0, and we store it in the variable called data frame of rainfall that is filtered. And then using display function you can display a few rows, first few or the first few initial rows of the newly filtered data frame. And then the very next thing we do, like we did previously, using dot plot and scatter, we can plot the filtered rainfall data frame and giving the parameters as x is equal to year, y is equal to rainfall, and the label is also mentioned rain year. So similarly we can get the plot. Here the outliers have been removed, or you can say filter activity is done. The very next thing is to combine the data using Pandas merge. As you have observed previously that both the data frames are separate and different from each other. Like they have year and rainfall, and they have year and temperature, and year and rainfall. Now what we do, they have a common column called year. What we do is we merge the data frame on the column year. So how we do that, let's see. Yeah, we form a new data frame called df merge, and using dot merge from pandas we will pass the data frames, the temperature one that is filtered and the rainfall one that is filtered, and on what column we are doing this is year. And how we are doing is outer means, here outer means that the missing values will be considered, and if we put the parameter how is equal to inner, then the missing values will be neglected. I will test both of them. Then simply we display the newly formed data frame called df merge, data frame merge, and we can get the info for a better idea what is happening actually. So you can see in the output the data frames have been merged, and here from info we get that there are total of 61 non-null values in the year column, and in the temperature column there are probably two missing values, therefore 59 non-null values. And here we have total of 4 missing values in the rainfall column, so we have 57 non-null values. So you can also observe these are the missing values in the temperature column, and you may have some missing values in the rainfall column as well. Now in order to remove these missing values which we do not want to deal with, so again I have copied the code from the previous cell because it has to be similar. Only this a parameter how is equal to outer will be replaced with how is equal to inner, and I already mentioned why inner is used because we want to neglect the missing values. So this is the only change I have made in the cell, and when I run the cell this is the output I get. You can observe there are no missing values or not a number and nan values. And you can also check the info now. For the column year there are a total of 55 non-null values, same is for the temperature and the rainfall column as well. So we have dealt with the missing values also. The very next task is of sorting the data by the rainfall and temperature. By either of the columns you can sort the data. So in this cell I have gone with the column called temperature. By which column? By temperature column I am actually sorting the data. So in the variable which I store is data frame merge sorted, and using dot sort values I have sorted by the column temperature. And when we look at the when we directly display the newly created data frame, you can just check the values are sorted like from the index. If you observe the index, like 6 at index 6 in the year 1962, the minimum temperature is there, that is 8, followed by 9.55, which is the very next high temperature, and at last you will have the highest temperature which is 38.01 in the year 2012, and this is at the index 50. But the other thing is that for the rainfall column it depends on the temperature column. The corresponding rainfall amount will be mentioned. Like for 8.77 it's 2.0, and in the last one, the rainfall for when the temperature was 38.01, the rainfall was 3.00. Similarly, you can sort by using the column rainfall. I've copied the code because it's totally similar, and using the same function dot sort values. Only this time we are sorting by the column rainfall. So you can see uh, in the output, new data frame has been created. Here I have overwritten in the same variable, and you can see in the rainfall column the sorting has been done. You can see the first value is 1.01, followed by 1.32 and 1.45 and 1.5, and gradually this will increase, and at last you can see the highest rainfall amount is 5.6 0, and the corresponding temperature is 30.40 degrees, and this was in the uh, year 2000, and this all these three datas are in the are in the row of index 39. So is the descending order sort possible? Obviously, in the previously cell lines of code, you just have to add one more parameter to the dot sort values function. Ascending is equal to false means obviously this will be giving you descending for all the values in the rainfall. So now the 5.60 has come up. Sorry, has come up, and the minimum value will be at last, that is 1.01. Now using Cbond, sorry, I'm getting this problem. So the last task is of using the Cbond package to create the regression plot, and this regression plot works on two variables right now in this in our case, and which is rainfall and temperature, and on which data it is working on is df merge that we previously created, and it basically gives the relation, like what is the relation between these two variables. So using using Cbond, I've imported it as using the alias SNS. So SNS dot regression plot, and the parameters are obviously x-axis. I have given the rainfall. This is the first variable. The y is given as temperature, the second variable, and on which data frame we are working on exactly. The data is equal to df dot merge, and then obviously we use the matplotlib function plt.show to show the regression plot that will get formed. So this is a regression plot that gets formed, and you can check out what the correlation is.